questions.
I will give each other one question.
Okay, so these 6 questions, which you would like to solve?
The odd. And you will solve the even.
The even?
Yes.
Okay, so you'll start with question 1. Question 1 is integral, bracket 2 plus cosine x, bracket dx. This question is actually quite simple, right?
Yes.
Write it below. Not 2 to the side. If not, you'll get out. So cosine x is actually
Sin
x. Correct. Okay, next is the second question. The second question is integral secant square bracket 2x bracket dx. So for this, first we can make these two the same, right?
Right.
So first we have this half, which becomes like this. So this part is actually like this, right?
Correct.
And don't forget about the arbitrary constant.
Yes.
Next, on to the third question.
Okay. Read out the question.
Okay, the third question is integral 3 sine 2x plus 1 over 3. That is bracket dx. So first for this, the 3 can actually go in front.
To say bye-bye.
And also remember, you can actually separate this, right?
Wait. But actually what I want to do is say bye-bye to another guy. So now to start.
Wait, what do you want?
We need to take out 2 over 3.
The 2 over 3.
Reciprocal.
Comes out is a 3 over 2. So it's a 3 times 3 over 2, which is a, yes, 9 over 2. And remember, if you separate it, it's actually much clearer. That is a 2x over 3 plus the 1 over 3. Because that 1 over 3 is a constant, so you don't need to care about it. And it's just the 2x over 3. So that's why you can get out a 3 over 2.
Okay.
So like this, when you continue, there's a 9 over 2 here, and then here the sine, which comes from a cosine, and remember you have to have a negative. And what's inside here stays the same because that these two are the same.
Yes.
And also at the end, don't forget the arbitrary constant, right?
Yes, arbitrary constant.
Okay, next, move on to the question number 4, which is integral 4 cosine bracket pi over 4 minus 2x bracket dx. So first for this, 4 you can put it on the outside row.
Yes, and out the row.
So then like this, because they're here, for inside the d you need the pi over 4 minus 2x. So here's already a 4, right?
Yes.
Then you need this negative, and then you need to times another half.
Okay.
Am I right? So like this, so what calculate what is it?
So it is actually 2.
Negative 2, right?
Yes.
So this negative 2 and this, which is a sine this thing. So we are negative 2 sine bracket pi over 4 minus 2x bracket plus the arbitrary constant.
Yep.
Well, is it too fast?
No.
Okay, good. Next, on to the 5th question.
Number 5. And please read out the question.
So this is integral bracket 3 plus sine bracket 2x plus pi over 4 bracket dx.
You may separate.
Separate, right?
Yes.
So when you separate, this is actually a 3, the integral 3 dx, and plus this together with these, right?
Yes.
This thing copy.
I just wanted to write this bigger.
And that is a
B.
okay, so next for this, what will happen?
This is the easy part.
Yes, correct. That is a 3x that you need to plus because their sine comes from a cosine, and cosine when you
And
differentiate
don't
your
forget your
negative.
arbitrary constant.
Okay, but because that is not the actual one, so you can put a c prime, and when it comes to the whole thing, you can just put it as c.
I need the space because someone going out.
Where's your bracket? And because that at the back you need it to be the same as this, which is a 2x plus pi over 4. So in front you need a half, yes. And next step, write it over here. So right now you can integrate, right?
Yes.
And also when you integrate, you shouldn't forget something.
Arbitrary constant.
Yes, and you don't need that c prime anymore because that c prime, it can go together with the one at the back. Right?
Yes.
So the one at the back, sine comes from the cosine. But cosine, when you differentiate, is actually a negative sign. So you need a negative cosine. And don't forget about that half. So this will be a negative half cosine 2x plus pi over 4. Then after that, you need to plus c. So like this is the answer, right?
Yes.
So next on to the 6th question, which is the integral to tangent square x
And
dx.
then nearly to the end for this, but not the end of this lesson. We also nearly the start for our own questions.
So this will be a 2 integral tangent square x. We can write it as sine square x over cosine square x, and here's the dx. So here can be 2 integral. So sine square x, we can use the trigonal identity, right?
Yes.
Which is a sine square x plus cosine square x, which is a 1. So sine square x will actually be a 1 minus cosine square x. So like this is 1 minus cosine square x, then go over the cosine square x, and here's the dx. So for this, here's the 2 integral, we can separate these, right?
Okay.
So like this, you have this 1 over cosine square x minus a 1, and here you bracket together times the dx. Then like this, for this, what is 1 over cosine square x?
1 over cosine square x is secant
Square x, right?
Yes.
So for this, remember about this secant square x, which we have done just now, which is the tangent to x, right?
Yeah.
So for this 2 integral this thing, so first we had this 2, and then behind here, remember, it's an x. So here is the tangent x, and then you will need to, don't forget about that, minus 1, which is actually a minus x, right?
Yes.
So this minus x will actually become a minus 2x, and then you need to plus the c.
Okay.
Correct?
Correct.
Okay, so everyone can understand these 6 questions.
But not the end.
Everyone can understand until here?
Okay.
Okay, so next we'll have our own questions. Okay?
Okay.
Okay, so we can start writing our questions, okay?
Okay.
So for this, we'll write our own questions for each other. They can be the same pattern. You can just change the numbers and they might actually change the whole thing, right?
Yes. The first, if you want to add more, best is to start with the square bracket.
So like this, you can add a lot more, right?
Yes.
So for
And the
this,
first phrase will be enough. I already start the first step.
okay, so I'll just write this question above because this space might not be enough.
Okay.
Okay, so right now we can start solving, okay?
Okay. prime because they're not the actual one.
The actual answer, right?
Yes. They're not that predicting.
Need help? So this is the solution for this question. Bracket. Okay, so are you sure that that's the answer?
Yes.
So this is the answer, right?
Yes.
Okay, so just take a quick look at these two solutions, okay? Okay?
Yes.
So can we stop here? So these questions, some might look very hard, but it is just complicated, okay?
Yes.
So for this time, can we stop here?
Okay.
Okay.
Bye.
Bye.